Okay, Common Core Algebra 2, this is going to be Chapter 1, Section 7, the second part. We're going to look at absolute value inequalities today, and this is actually our last lesson for the first chapter. So it's going to be very similar to the last one when we talked about absolute value equations, except for now we're going to just switch that to inequalities. So remember, we're going to have things like r less than, greater than, r less than or equal to, or r greater than or equal to. And then after we do those, we're going to graph those absolute value inequalities, which you're going to want to remind yourself about a compound inequality as an and, or, an or inequality. Okay, so first thing, like we said, an absolute value inequality is just like an absolute value equation, where we're going to have an, but it's an inequality instead of an equation. The variables inside are absolute value. And we're going to solve it. It's always going to create a compound inequality. Like I just said, that's going to be an and or an or. The only tough part with these is remembering which one becomes and which one becomes or. So anytime you have the less than or the less than or equal to symbol, that's the important piece. Less than or equal to becomes an and inequality. So this one, for example, we would write as, we're going to write our absolute value, whoops, we're going to lose our absolute value. So we're going to have 3x plus 6 is less than 15, and because it's and, we're going to make it greater than the opposite of this, negative 15. Okay, if it has the greater than or the greater than equal to piece, then it becomes an or inequality. So same example here, except for we switched our symbol. So we'd say 3x plus 6 is greater than 15, or 3x plus 6 is less than negative 15. So two things there. You notice we flipped our symbol and we also changed the sign. Same idea here. We changed the sign to become a negative 15. That's really important when we're solving, because remember, we're going to have an infinite amount of solutions for this. So in order to solve it, first thing we want to do is isolate the absolute value, just like we did with an equation. First step, we're going to add 7 to both sides here. So we end up with our absolute value of 3x minus 6 is less than or equal to 12. And then after we do that, we decide is it and or. So that's the previous side. We have less than. So this is going to be an and in this case. Remember, it's not always and. But I'm going to rewrite this as negative 12 less than or equal to 3x minus 6 less than or equal to 12. And then you solve that compound inequality just like we have in the past. I'm going to start by adding 6 to all sides, which is going to give us a negative 6 is less than or equal to 3x is less than or equal to 18. Divide all three sides, remember, by 3, which gives us a negative 2 is less than or equal to x is less than or equal to 6. And remember, this symbol doesn't switch just because we divide by 3, even though this is negative. The number we divide by has to be negative. So that would be our and inequality that is our solution for the compound inequality. And now we want to graph it the same way that we graphed compound inequalities, and you may want to review 1.6 Part 2 notes and that video. So you see we have the same inequality here that we solved before. So if I put 0, and then I count by 2's, both of these are going to be closed circles because we have the or equal to piece, and values that would make this true would be in between the shared space. So we're going to shade in between. Hey, that is it for this lesson. Big thing is you have two ways to remember. You need to know, is it an and or an or? So and versus or. Remember, that has to do with less than or equal to, or is greater than or equal to. And other than that, you solve it just like you would solve an absolute value equation, where you isolate the absolute value first and you graph it just like you would do compound inequalities. All right, we'll see you in class.